Okay, yeah, I'm Georg Northoff from Canada, neuroscientist, psychiatrist, and philosopher. How usually it's the way that we look in neuroscience to artificial intelligence to learn something from AI. However, I think that AI can also learn something from the brain. And the key component of the brain, that our brain, I will show this more, has different time scales: slow, short, long, fast. And it can react to all kinds of events. It can make predictions over shorter time, over longer time, less for longer time, but we can do that. So time is really key that may link the brain and also its mental features to the external world and the environment. And the environment bombards us with all kinds of different time scales, but we can react relatively flexible and adaptive to that. The problem with, I think, with current AI, as good as it is, it's amazing developed, it has no real intrinsic time. So when you look, I think it's, I'm not sure whether you see the title here, AI is good in very specific tasks, like the Go, the Go champion, chess, and so on. But it cannot do a variety of different tasks, look like here. Whereas we as humans, we can do that. So the problem is that the artificial agents cannot really navigate nor adapt to differential and continuously changing environmental contexts. Of course, they're getting better at it, but still I think that's a key problem. And that is called the generalization problem in AI, that they cannot address all kinds of different problems. How to remedy that? So meaning, how can we make AI more adaptive to changing, to contexts with different temporal and stochastics and dynamics? So the idea is that's where I think we can learn from the brain. Because the brain, there's a time that the brain has a real intrinsic time. It had its own inner time, which sometimes and not always completely synchronizes with the external time. So for instance, when you experience something much longer than it objectively is, that's your brain's intrinsic time. That discrepancy between the objective time duration and the subjective time duration, that's where your brain intrinsic time comes into play. So, and amazingly, the brain itself has different kinds of time scales. It's called intrinsic neural time scales. And I want to get into detail about this. You see here in the upper thing, you see sort of a time series over different time legs, and there's a correlation. The shorter time intervals more strongly correlate with each other than the longer ones. And that creates sort of different time windows. So imagine you have a house with just one window size, and you always see the same. But if you have different window sizes, you see different things. You see the branches, you see the leaves, and then through the big window, you see the trunk. So then you know, aha, that's a tree, and maybe you're in fifth floor. But if you have just a small window and not a large window size, you cannot see that you're in fifth floor or wherever. And the brain has all these kind of different time scales or time windows. Yeah, and you see this here. I don't want to go into detail. Different regions, particularly the regions in the middle of the brain, have the longest time scale. The regions which directly process the external input, sensory regions, have shorter time scale, which makes sense because they continuously need to adapt to the faster time scale of the environment. Why is that important for the brain? Because, and that's here in the middle of the slide, it's the key thing. The brain matches its own intrinsic time scales, its time windows, with the time scales of the environment. So it's the temporal stochastics of the brain intrinsic time scale matches with the continuous changing time scales of the environment. And that seems to be a stochastic, purely statistical matching process. And the better they match, the better you can synchronize. Like when you perceive music, when you listen to music, you automatically tap the beat. That's where your brain optimally synchronizes. And of course, if your brain is very fast, you probably like fast music, you can better synchronize with it. Okay, coming to the last slide. Now you can build in these time scales into the agent, and even more interesting now, you can try to build in time scales into the agents which are not present in the biological agent. And that should increase the perception and the cognitive capacities of the agent. Thank you.